So what happens when your router doesn't know where to send traffic? Today, we'll fix that with static routes, the foundation of routing. When are static routes useful? Static routes work best in smaller, more predictable networks where you want full control over the router's decision making. By configuring static routes, you can tell the router exactly where to send traffic. No guessing, no overhead. They're simple, reliable, and less resource intensive compared to dynamic routing. This makes them a great choice for branch offices, lab environments, or networks where the path is unlikely to change. The routing table is like a map for your router. It stores all the known routes and details about how to reach each network. The router uses this table to decide the best path for traffic. If a packet arrives and the router doesn't have an entry for that destination, the traffic is dropped. That's why understanding how to read a routing table is so important. It's one of the core skills in networking and the backbone of how routers make decisions. What are static routes? Static routes are manually configured paths that tells the router exactly how to reach a destination network. You set them using either a NetHop IP address or an exit interface. They're great when you want full control and predictability in your network, especially in smaller or specialized environments. Let's see how that works in Packet Tracer. Now, we'll configure a static route on R1, instructing it how to get to the 10.1.23.0 network by going to R2's G01 interface. Now, let's check the routing table. And there is our entry for the 10.1.23.0 network. What are floating static routes? A floating static route is a backup route that only takes over if the primary route fails, whether that's a connection issue or a network change. So what makes it a backup? By increasing the administrative distance, or AD, to a value higher than 1, which is the default for static routes, the router will only use this route if no better option is available. Floating static routes provide redundancy, improve uptime, and ensure traffic keeps moving even if a problem occurs unexpectedly. Now we'll configure a floating static route on R1 using the direct connection to R3. This route will serve as a backup path to reach the LAN behind R3. By raising the administrative distance above the primary route through R2, this backup route will only take over if the R1, R2 path fails. Now, let's check the routing table. Now, on R2, we'll configure a static route to reach the LAN behind R3 via R3's G00 interface. Now, let's check the routing table. And there is our entry for the 10.0.0.0 network via R3's G00 interface IP. Now, on R3, we'll configure a static route to instruct it on how to get back to the 192.168.12.0 network via R2's G01 interface. Now, let's ping the loopback interface on R3, which we're using to simulate a LAN behind the router. This will help us test that our static routes are working end to end. And here we see the static route that was implemented. Now, let's shut down R1's G00 interface and force it to use the floating static route via R3. Now, we see that the floating static route has been implemented. What are default routes? A default route is a manually configured route with the address 0.0.0.0/0, which matches all possible destinations. Instead of dropping unknown traffic, a router with a default route will forward it towards the specified next hop or exit interface. This ensures there's always a path, even for traffic the router doesn't have a specific entry for. Default routes are especially useful for simplifying routing tables and minimizing the number of static routes you need to configure, which makes the network easier to manage. Now, let's see how default routes work. We'll configure a simple static route on R1, telling it to get to the 192.168.23.0 network. Go to R2's G00 interface. Now, we'll configure a default route on R2, telling it, if you don't have an entry for this traffic, send it to R3. Then R3 will take care of the rest. And there is our default route entry in the routing table. Now, we'll configure a route on R3, telling it to get back to the 192.168.12.0 network. Go to R2's G01 interface. From R1, let's test connectivity to R3's interface IP. Now that we've covered the 3 static routes individually, let's cover them together in this lab. From R1, we'll configure two routes to the 192.168.20.0 network. The first one will be the primary route via R2, and the second will be a floating static route via R3. Once we check the routing table, we see our primary static route via R2. The floating static route will only appear once it's in effect. On R2, we'll configure two routes. First, a default route pointing towards R3, so any unknown traffic is forwarded that way. Second, a static return route that tells R2 how to reach R1's LAN. This ensures traffic from R3 can find its way back to R1. Now we see both entries in the routing table for R2. Next, we'll configure two routes on R3 to reach the 192.168.10.0 network behind R1. The first will be the primary route through R2. The second will be a floating static route through R1, which will only take over if the primary path fails. Here we see our primary route via R2. Now that we've configured all routes, we'll now test connectivity by pinging from PC1 to PC2. Don't worry about the initial timeouts. The ARC process is taking place. We'll test connectivity again and get successful replies. Now, let's see the routes the pings took to reach its destination using the command tracert followed by the destination address. We can see that the ping went to its gateway first, R2's G00 second, R3's G00 third, then to PC2. To complete the lab, let's disable R1's G00 interface to force the floating static route to take action. Now we see the floating static route is in the routing table. Next, we'll disable R2's G01 interface. As long as it stays active, R3 will see it as the best route. And now, the default route and the return route is no longer active. We'll ping from PC1 to PC2. Now, let's trace the route the pings took to reach its destination. We see R1, then R3, then PC3. Floating static route successful.